Good evening, children.
Good evening, ma'am.
Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening. Okay, we have to continue from here. So here L and M are two parallel lines. L and M are two parallel lines intersected by another pair of parallel lines P and Q. So L is parallel to M, P is parallel to Q. L parallel to M, P parallel to Q. Show that triangle ABC is congruent to triangle CDA. You need to show that this triangle ABC, this one, is congruent to triangle CDA. So see here, children, what are we given? We are given line L is parallel to line M and P is parallel to Q. This is what we have to prove. You need to start your solution like this. Write out whatever is given. Given L parallel to M and P parallel to Q. What is to be proved? To prove triangle ABC is congruent to triangle CDA. This is what we'll have to prove. And give the heading proof and write out the steps. So these angles will be used in the proof. So I've numbered the angles 1, 2, 3, and 4. You have to number them as and when needed. You cannot, before you start writing this, you cannot mark off 1, 2, 3, and 4. As and when you need, come back to the figure and mark the angles. Okay. Now in this method, ABCD is a quadrilateral. ABCD, we're going to prove this in two different methods. This is method 1. Am I audible, children?
Yes, ma'am.
Yes, ma'am. Audible.
All right. So in this method, ABCD is a quadrilateral. How do we show that it's a parallelogram? A parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. A parallelogram is a quadrilateral. It's a four-sided closed figure. A parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. Now, AD is a part of L, correct?
Yes, ma'am.
AD is a part of L, correct?
Yes, ma'am.
Yes, ma'am.
And BC is a part of M.
Yes, ma'am.
Yes, ma'am.
L is a line. L is a line. L is a line. AD is a segment. AD is a segment or is a line segment of L. And similarly, BC is a segment of the line M. But we know that L is parallel to M. So any segment of L will also be parallel to any segment of M. So since L is parallel to M, AD is parallel to BC. AD, which is a part of L, will be parallel to BC, which is a part of M. So AD is parallel to BC and okay, the opposite sides of the quadrilateral are AD and BC. ABCD is the quadrilateral. Opposite sides, AD and BC, they are parallel because they are parts of the lines L and M. Similarly, the other pair of opposite sides are AB and CD. The other pair of opposite sides of the quadrilateral are AB and CD. AB is a part of P. CD is a part of Q. So since P is parallel to Q, any part of P, AB, will be parallel to any part of Q, CD. So AB parallel to CD. So because L is parallel to M, we have, because L is parallel to M, we have AD parallel to BC, this one. And since P is parallel to Q, we have AB parallel to CD. So what does this mean? In the quadrilateral, both the pairs of opposite sides are parallel, and hence ABCD is a parallelogram. All right. Now we proved that ABCD is a parallelogram. We proved that ABCD is a parallelogram. Now now that it's a parallelogram, it has so many other properties. It has so many other features. Once you proved that ABCD is a parallelogram, you can apply all the properties of the parallelogram to ABCD. Now we know that in a parallelogram, opposite sides are equal. In a parallelogram, opposite sides are equal. So now take up the triangles which we have to prove are congruent. So this is the preparation. Before you take up the triangles and show that they are congruent, this is the preparation. We are preparing, meaning we are proving, we are trying to have this, we are trying to say that this triangle, this quadrilateral ABCD is a parallelogram. Okay, now take up the triangles ABC and ACD. Take up the two triangles which have to be proved are congruent. Now in these two triangles, AB of the, see, when I say the first triangle, it is triangle ABC. Second triangle is ACD. First triangle is ABC, second triangle is ACD. You can also take ACD as a first triangle and ABC as a second triangle. And the way you name the triangles here is not at all important. You can write ABC, you can write BAC, you can write CAB. The order is not important here. ABC, ACD. We're just referring to this triangle and this triangle. You can also refer to ABC as BAC. BAC is also this triangle. All right, now in these two triangles, so we need to write three pairs of equalities satisfying any one of the any one of the five congruence conditions. We need to write three pairs of equalities in these two triangles satisfying any one of the five congruence criteria. So we need to, even before you write, you need to first check the equalities available and decide the property and decide the congruence rule. Okay, so in this triangle ABC, we have the side AB, and in the other triangle, okay, in the first triangle we have the side AB. In the second triangle we have the side CD. But AB is equal to CD because they're the opposite sides of the parallelogram. AB is equal to CD because they're the opposite sides of the parallelogram. They're equal. So AB of triangle 1 is equal to CD of triangle 2. That's the first equality mentioned here. Because we know ABCD is a parallelogram, opposite sides are equal. Again, BC of the first triangle. See that's important. We are not just writing some three equalities. One side or one angle of the first triangle is equal to one side or one angle respectively of the second triangle. Simply if we write something equal to something will not become valid steps here. BC of the first triangle is equal to AD of the second triangle. Because again, it's ABCD is a parallelogram, opposite sides are equal. And AC is a side common to both the triangles. AC is equal to AC common side. So we have listed three equalities satisfying the SSS congruence criterion. Three pairs of equal sides. These sides AB, BC, and AC are the sides of the first triangle ABC. The sides CD, AD, and AC are the sides of the second triangle ACD. And they're equal. We have justified why they're equal. Simply, we cannot write AB is equal to CD. Why is AB equal to CD? Because in the parallelogram ABCD, we know that opposite sides are equal. So AB is equal to CD. And finally, we need to name the triangles in the correct way.
Ma'am.
1 second, Shreyas, let me just finish. So we need to name the triangles in the correct order. So I've told you, take up any two equalities. Now this is, take up any two equalities. Now this is AB, BC. AB, BC, B is common. And now what's common here? CD and AD, what is common?
D, ma'am.
D is common.
So CD, DA. CD, DA. AB, AB, B. Take up any two equalities, I said. Not the first two, any two equalities. Any two pairs of equal sides. So if you look at the first two, AB, BC, B is common. So ABC, triangle ABC. Okay. The second one, CD, AD. Okay, let's write it as CD, DA. So CDA. So you can see here, triangle ABC is congruent to triangle CDA by the SSS congruence criterion. And that's all we had to prove. So we have proved that the two triangles are identical. Shreyas, please hold your question. Let me explain method 2 and then I'll come back to your questions. In fact, anybody who has a doubt with this, please get back. Finish the second method.
Okay.
So in the other method, so here we've made use of only the sides. Here we made use of only the sides. Only the sides, you know. We've written 3 pairs of equal sides. SSS rule, the triangles are congruent. Now it is for this one that the numbers 1, 2, 3, 4 are used. So you can see that see here, some line, transversal, a line. See here, line, transversal, line. But these are parallel lines. It's a parallelogram. In fact, we know that P is parallel to Q. So we know that AB is parallel to CD. Is parallel to CD. So line, transversal, line, where these two lines are parallel to each other. AB is parallel to CD. So angle 1 is equal to angle 2. Alternate interior angles are equal. Because you can see I've mentioned here which are the lines parallel. You can write AB parallel to CD or you can write P parallel to Q. Both are fine. You can write P parallel to Q or you can write AB parallel to CD. Both are fine. Which is the transversal? AC is a transversal. P is parallel to Q and AC is the transversal. See, this is the transversal. This one is the transversal. Alternate interior angles are equal. And then see here, parallel line, transversal, parallel line. Parallel line, transversal, parallel line. Because L, this is L, transversal, and this is M. L is parallel to M. L is parallel to M and AC is a transversal. See the Z being formed. See the Z. These are the parallel lines. These are the parallel lines. Now these angles are equal. Alternate interior angles are equal. So angle 3 is equal to angle 4. Can you make out that angle 3 is equal to angle 4? So L parallel to M, AC is a transversal, alternate interior angles are equal. So now we have mentioned 2 pairs of equal angles. 2 pairs of equal angles. So we have mentioned 2 A's. So if you want to use the ASA, if you want to use the A, you can use AAS also here. You can also use the AAS rule. So the rule is depending on what equalities you have mentioned. So if you want to use the ASA rule, then you must mention then the included sides in the 2 triangles must be equal. So when you look at the 2 triangles, we have mentioned about angle 1 and angle 3 in the first triangle. We have mentioned about angle 1 and 3 in the first triangle. So which is the included side? In the first triangle, we have mentioned about angle 1 and angle 3. So only when you take a note of the angles, you can make out the included side. So look at the first triangle. The first triangle ABC. ABC is the first triangle. We have mentioned about angle 1 and angle 3. So that means AC is the included side. AC is the included side. So take the triangle separately. Take the triangle separately. This is angle 1. This is angle 3. So this is the included side. This one is the included side. For angle 1 and angle 3, AC is included side. So you must write AC here. You must write AC. If you want to use the ASA rule. Then in the other triangle, the other triangle is triangle ACD. See, triangle ACD, triangle ACD. Okay. So here we have mentioned about angle 2 and angle 4. We have mentioned about 2 and 4. Okay, so 2. We have mentioned about 2 and we have mentioned about 4. So angle 2 and angle 4 contain the side AC. We know that AC is a side common to the two triangles. So AC is the included side. So it so happens that AC is the included side in both the triangles. Angle 1 and angle 3 include AC. Angle 2 and 4 also include AC. And AC is equal to AC. Included side is the same side. It's a common side. So AC is equal to AC, common side. So we've mentioned one pair of equal angles, another pair of equal angles, and the included sides equal. So by ASA congruence criterion, you know how to name it, children. You know how to name the triangles. Okay, let's see it anyways. So by the ASA congruence criterion, the two triangles are congruent to each other. So when you know two pairs of equal angles, it's so easy to name the triangles, you know. When you know two pairs of equal angles. So you name one triangle. Name the first triangle. Now we have mentioned about angle 1 and angle 3, right, in the first triangle. So which is the angle 1? Which is the angle 1 in the first triangle?
A, ma'am.
One second. All right. Yeah, I was asking you. Which is angle 1? I'm sorry, I didn't pay heed to your answer. Yeah, which is angle 1 in the first triangle?
A, ma'am.
Which vertex? Yeah, vertex A. Vertex A. And which is angle 3 in the second triangle? In the first triangle, sorry.
C, ma'am.
C. C. So complete the name of the first triangle. AC.
ACB.
ACB. Now, yeah, write the name of the other triangle by using the corresponding vertices. So now angle 1 goes with angle 2. So which vertex is 2 in the second triangle?
C, ma'am.
Angle DCA.
C. C.
ACD, ma'am.
Yeah, which is angle 4 in the second triangle? A.
A, ma'am.
A. So CAD. CAD. So now you can see here, we have written ABC, CDA. That's because we've just copied, you know, we had to prove ABC is congruent to CDA. So we just wrote that. You can also check if this is right. This is what is given, but you can also check if you have understood it correctly. So see this order, ACB congruent to CAD. So if you write it as ABC, then it will be CDA. Yeah, it's right. ABC, CDA. Is also a valid or is also a correct way of writing the congruent triangles, naming the congruent triangles. ABC congruent to CDA, or you can say ACB congruent to CAD. Somebody tell me if I write BAC congruent to triangle BAC congruent to triangle BAC congruent to
CAD.
CAD, ma'am. CAD, ma'am.
BAC congruent to
CAD. BAC, ma'am.
BAC. Third vertex, first vertex, second vertex. BAC.
BCA, ma'am.
Sorry. BA and then C. So it will be
DCA.
DCA. DCA. DCA. If you say BAC, then you must say DCA. Yes or no, children?
Yes, ma'am. Yes, ma'am.
Yeah, so here we have mentioned, so you should decide. See, now there's so much of information because it's a part, because the two triangles are the triangles in the parallelogram. There are so many properties. There are so much of information is available, more than what you need to prove that they are congruent. So you must check all the properties, check the properties, and make out the equalities available, and decide which condition you don't have to prove it in both the ways. So you're going to write. You're going to prove it in any one of the two methods. So you should decide if you mention these three, then say SSS. So that means you should have prepared beforehand. You should have checked the equalities available and you should have decided the congruence condition beforehand. So if you wanted to use SSS, you must write the equalities to satisfy the SSS rule. Yes. Shreyas, I'm done. Please ask me. What's your doubt?
Ma'am, no, ma'am. In that first one, now you have in that proof, ma'am. ABCD is A is parallel to GM, like that. You have written, no, ma'am.
Which line? In method 1, is it?
Yes, ma'am. Method 1.
Yeah, tell me in method 1.
Ma'am, there is no G in the figure, ma'am.
Oh, where is G?
Yes, ma'am. It's AD, I think so, ma'am. AD is parallel to BC. No, ma'am. It's LM, ma'am. It's not GM, ma'am.
Oh, I did not note to that. I'm still not able to find it. Where is it?
Ma'am, in method 1 first. In method 1, in A, it's like AB is equal to CD. In bracket, ABCD is parallel to GM. You have given like that, ma'am.
Ma'am, that
That's
proof
LM,
for
ma'am.
triangle ABCD is congruent to triangle CDA.
Method 1 or method 2?
Method 1, ma'am. In A is parallel to GM, there, ma'am.
No, this line? No, this line, no. This line?
No.
This line? This line?
Yes, ma'am. Yes, ma'am.
Oh.
That before line, ma'am.
Okay.
There's no G in the figure, no, ma'am.
In a parallelogram, this is. Oh, sorry. This symbol, is it? This. Okay. Sorry. That's what I was not able to make out. Okay, 1 minute. Are you talking about this one? Are you talking about this one, Trace?
Yes, ma'am.
Okay, that's a symbol for a parallelogram. Parallelogram like this. In a parallelogram, opposite sides are equal.
Ma'am, no, ma'am. He's asking that there is no G in this figure, ma'am.
You're talking about this G, is it?
Yes, ma'am. There is no G, no, ma'am, in this figure.
Ma'am, I understood that parallelogram short form is that only, no, ma'am.
Okay, short form. Yeah, short form for a parallelogram is this one. Like we use this for a triangle. Triangle. When you say quadrilateral, ABCD, you can just write quadrilateral like this and write ABCD. ABCD. Quadrilateral ABCD. When you want to say parallelogram, you can just say parallelogram like this. This stands for parallel, and GM, parallelogram, GRAM, so short, parallelogram ABCD. This G is for the this full thing is parallelogram. Still not following?
Ma'am, understood, ma'am.
Okay.
Yes, ma'am. Okay, ma'am.
Ma'am, I do understood, ma'am.
All right. Yes, what doubts you have, children?
Ma'am, no doubts, ma'am. No doubts, ma'am.
Okay, if I want to use the AAS congruence rule, then tell me what are the equalities that must be listed to use the AAS. I want to use, see, I want to do it in two more methods. I want to use the AAS rule, and I also want to use the SAS rule. I also want to use the SAS rule and prove that they are congruent. So if I have to use the AAS rule, what are the equalities I must mention?
Ma'am, two angles on the side.
Yeah, tell me, no. Tell me the equalities.
AC
Ma'am, the angle of first triangle.
Yeah, I'm waiting. I'm waiting. Yes, please tell me. First, tell me for AAS.
Ma'am, for this figure, ma'am.
Yeah. All of you try in your notebook and read from your book. Work for both AAS and SAS. If it is given, sometimes it will be specified. Prove that triangle ABC is congruent to triangle CDA using the SAS congruence rule. Then you have to use this rule. So that means the information or the equalities which you list must satisfy this rule. Sometimes the congruence condition also will be specified. Prove that the two triangles are congruent under this rule, under the ASA rule, under the SAS rule.
Ma'am, for AAS means, ma'am, angle BAC is equal to.
Excuse me. Now, what I want you to do is write in your book and take a picture and share it on WhatsApp with me.
Okay.
All of you, please work this in your book. AAS and SAS. Work in your book, take a picture and put it on WhatsApp for me. Let me check. What's happening, children, at your end?
I'm just doing it, ma'am.
Okay, I've not received anything so far.
Ma'am, I have just shared my solution.
Yeah, let me see. Please use the numbers and share again. Use the numbers one. Please use the numbers 1, 2, 3, 4.
Okay.
No, it shouldn't take this long, children. It shouldn't take this long. If
Ma'am, I'm just changing my numbers.
If AC is the included side, then other than AC will not be the included side. You just have to write two pairs of equal angles and one pair of equal sides, which is not the included side in the two triangles. What's difficult in this? Try. Excuse me. Yes, Kanishka, you're absolutely right. Very good. So you've done using the AAS congruence rule. Now try SAS.
Okay, ma'am. I'm using Penhouse.
What happened? You're using?
Ma'am, I'm using Penhouse phone, ma'am. He's also here. Actually, my phone is hanged, so.
Oh, yeah. Okay, if you can share it. Otherwise, just let me know that you've done it. That's all.
Yes, ma'am. I will share it, ma'am.
Yeah, do that. Yeah, Kanishka has shared the proof using AAS rule. She's right. No, Shreyas, for AAS, what the equality you've written the equality is similar to ASA. No difference. You check what you've written. You've listed the same three equalities. No.
Ma'am, sorry, ma'am, I can't understand.
The equalities, the pair of equal sides which are mentioned for AAS is incorrect. The pair of equal sides which you have mentioned for AAS rule is incorrect. Yes, SAS is right, Shreyas. For SAS, you've mentioned the equalities correctly. But what you should maintain is, in the LHS, the details must be about the first triangle equal to, in the RHS, the details must be about the second triangle. That you've just mixed up. So, but it's okay. It's not incorrect. You should maintain that discipline in writing.
Ma'am, for AAS, the sides with the equal sides are incorrect, ma'am.
Yeah, that's what even I said. Otherwise, good, Shreyas and Kanishka. What about the others? Hitesh?
Ma'am?
No, I don't. My question is already known to you.
Yes, ma'am.
Yeah. Where is your photo? Are you trying?
Ma'am, the phone is not with me, ma'am, so I cannot send the photo now.
But have you tried it?
Yes, ma'am.
Arav, Vasudevan, Nikita, Nivedita, Pranav, Satvika, Shivani, Tarun. Okay. So I have to request children. See, on demand she's shared Satvika. Method 1. What is this? Satvika?
Yes, ma'am.
Yeah, Satvika. I think by mistake you've written AB parallel to DC. Should we write AB equal to DC or AB parallel to DC?
Sorry, ma'am.
Yeah. Okay, so you've written AB is equal to DC. Let me mark that. You have written AB is equal to DC. Yeah, you're right. Opposite sides equal. BC equal to AD. BC equal to AD. That's also right. Opposite sides equal. Okay. Now, which do you think is the included angle for these two sides? These two sides include which angle, Satvika? You have written angle 3. Is angle 3 included by these two sides?
No, ma'am.
Yeah, so which is that angle?
Angle D.
Angle B. Use 3 letters and name the angle.
ABC.
Yeah, so maybe we can call it 5. Angle 5 is equal to?
Angle ADC.
ADC. ADC. So see here, now the sides AB and BC include angle 5. AB and BC are the arms of angle 5. Similarly, in the other triangle, CD and DA, they are the arms of angle 6, which means 6 is the included angle. These two sides contain angle 6. These two sides contain angle 5. So you should have written 5 is equal to 6 or ABC equal to CDA for SAS congruence criterion. So otherwise it becomes SSA. SSA is not a valid congruence rule. Okay, I should say thanks, Satvika, for sharing on demand. What about the others?
I was working out, ma'am.
All right.
I was
Okay.
about to start.
Okay, fine. Don't take me too seriously, yeah. What about the others? I need to call out again. See, some of us
Ma'am,
are
I
not.
have corrected mine and shared, ma'am.
Okay. See, some of us don't unmute to share your thoughts, but at least you can share the picture.
Ma'am, I have shared you the SAS congruence criteria also, ma'am.
Yeah, we'll see. SAS, is it? Okay. Very good. Perfect, Kanishka.
Thank you, ma'am.
Yeah. Shreyas. Yes, Shreyas, you have corrected it. You're right.
Okay, ma'am.
Shreyas is right. Both the ways he's done it correctly. Kanishka is also right. Satvika shared one method. I'm waiting for the other one. What about the others?
Ma'am?
Yeah. Yes, Shivani.
Ma'am, actually, I'm not having my phone.
Okay, read out your proof, Shivani. No problem. Read it out.
Ma'am, what, ma'am?
Please read out what you've written. I said you're not able to share, so you can read it out.
Ma'am?
Children, if you're not able to share your picture, let me know. Let me know if you're not able to share your picture. At least I'll ask one of you to read it out. Shivani, you can read out your proof, I said. All right, so I don't think it's wise to spend more time on this. So I leave it to you. You have to try. You have to try to prove these two triangles are congruent under the SAS and the AAS rule. So see, except for the RHS, we can use all the rules, except for the RHS rule. Except for the RHS rule. See, you can prove that these two triangles are congruent using the SAS rule, AAS rule. Some of you shared the proofs, and then not some of us, two of you, three of you. And see here, we have already proved using SSS and ASA. SSS and SSS and ASA, you can see it here. You can also prove using SAS and AAS, which means except for RHS, you can prove this using any one of these four criteria. All right. So in this figure, look at, see, understanding the information given is very important.
Ma'am.
Yes, Shreyas? Okay, I can now see the pictures from Satvika and Ananya. Let me go back to the earlier one. Satvika says angle is equal to 2, 3 is equal to 4. Good, Satvika. AS criterion also. You have listed the equalities correctly. Good. Ananya. Okay, Ananya, you have shared using the SAS rule. Equalities are correct. Good. So children, here, line L. See here, this line L. This line L is the bisector of angle A. Is the bisector of angle A. See here, this is angle A. This is angle A. These are the arms of angle A. AP, ray AP and ray AQ. Ray AP and ray AQ are the arms of angle A. Correct? Correct, children?
Yes, ma'am.
Ray AP and ray AQ are the arms of angle A. Now, this line L bisects angle A. This line L, it bisects, meaning it divides the angle into two equal halves. This line L bisects angle A, which means angle QAB is equal to angle PAB. Correct? QAB equal to PAB.
Yes, ma'am.
Or you can say angle. You can say angle BAQ is equal to BAP. All right. So this is one thing given to us. And then BP and BQ are. Yes, Shreyas?
Ma'am, we can also say that angle BQA is equal to angle BPM. Ma'am.
Angle?
BQA is equal to angle BPM.
Yeah, that's the next thing we are going to see.
Okay.
Okay, so BP and BQ are perpendiculars. BP and BQ are perpendiculars from B to the arms of angle A. So these are the arms of angle A. This is one arm, this is the other arm. BP and BQ are perpendiculars. That's why it's marked 90 here. They are perpendiculars from this point B. B is any point on L that's given to us. B is any point on L. BP and BQ are perpendiculars 90 degrees from B on the arms of the angle. So given this information, we need to prove that the two triangles here and here, this triangle and this triangle, they are congruent to each other. And we also need to show that BP is equal to BQ. So that will follow once you show that these two triangles are congruent. BQ is equal BQ is equal to BP will follow from CPCTC. So we need to show that these two triangles are congruent. Why is angle 1 equal to angle 2?
Ma'am,
Because
L is the bisector
angle
of
A.
angle 1 and angle 2.
L is not the bisector of angle 1 and angle 2.
Ma'am, it bisects angle A, ma'am. So
Yeah,
it divides into two parts, ma'am. So it would be equal, ma'am.
Very good. Is that Nivedita?
Yes, ma'am.
Okay, very good. So L, name the angle using 3 letters. Nivedita or Niveda?
Nivedita, ma'am.
Nivedita. All right, Nivedita. You name the angle. Name the angle using 3 letters.
Yes, ma'am. Ma'am, A, B, P, A, and Q, Q, B, A, ma'am.
No. I said name angle A using 3 letters.
Ma'am, I can't understand.
No. There's an angle formed at the vertex A.
Can I?
There's an angle formed at the excuse me. There's an angle formed at the vertex A. Name that angle using 3 letters.
Ma'am, can I, ma'am?
Okay, Shreyas.
Ma'am, angle QAP, ma'am.
Or
Ma'am, or angle PAQ, ma'am.
PAQ, ma'am.
PAQ. PAQ. Or QAP.
Yeah, ma'am. Now I understand, ma'am.
Yeah, very good. So L bisects angle A, that is angle PAQ or QAP. And when it bisects, the two halves of angle A are angle 1 and angle 2. The two halves of angle A are angle 1 and angle 2. Obviously, angle 1 is equal to angle 2. Why 3 and 4 are marked 90 degrees?
They are perpendicular. Ma'am, they're perpendicular, ma'am.
Where is the point B? Where is the point B?
In the L line here.
B is any point on the line L. Correct?
Yes, ma'am. Yes, ma'am.
Okay. Now, what is BP?
90 degrees.
No, how do you express? What is BP? B is any point on L. What is BP? What is BP? How do you express BP? Don't say blood pressure. We're not doing science. BP. Okay, let me say that. BP is a perpendicular from the point B to one arm of the angle. BP.
I'm told that, ma'am, it was Ma'am, could you repeat that, ma'am?
Yeah, BP is a perpendicular from the point B to one arm of the angle. One arm of the angle. Now tell me what is BQ?
And BQ is the perpendicular to the one arm of the angle.
BQ is a perpendicular. From where?
And from the B, ma'am.
From B. From
Ma'am,
B.
from the point B.
From the point B to the angle, ma'am.
To the other arm of the angle.
Yeah, ma'am. Other arm of the angle.
Yeah. Now repeat. What is B? What are BP and BQ? BP is
perpendicular, ma'am, and it's
you must use the words from and to. BP is a perpendicular from. You must use the BP is a perpendicular from the point B to one arm of the angle. BQ is also a perpendicular from the point B to the other arm of the angle. I'm sure you all understood that. So since BP and BQ are perpendiculars, you can see angle P and angle Q marked 90 degrees. So angle 3 is 90, angle 4 is 90. Who bisects angle A?
L, ma'am.
L bisects angle A. So what is the consequence when L bisects angle A? What happens?
Ma'am, it divides into two equal parts, ma'am, which forms
Which
a
are the two equal?
perpendicular angle.
Which are the two equal parts?
Angle 1 and angle 2, ma'am.
Angle 1 and angle 2. So this is what is given to us. Angle 1 is equal to angle 2 because L bisects angle A. Then angle 3 is 90. Angle 4 is also 90 because BQ and BP are perpendiculars from the point B to the arms of the angle. To the arms of the angle. Now read the question. It will make more sense. Please read the question given. Is the question more clear now? Is the information more clear now?
Yes, ma'am.
I want all of you to read the information given and apply it. See the same in the figure. Read the information and see the same in the figure. So now we need to show that these two triangles are congruent, this one and this one.
Yes, ma'am.
Yeah, now tell me how many of you are ready to answer this? Gather all the equalities in your mind and have the congruence rule ready. Gather the equalities, keep them in your mind and also decide the congruence rule. How many of you can tell me, announce your names?
Ma'am, I can't understand the question correctly.
No problem, you wait. Others?
Ma'am, I can tell the congruence rule, ma'am.
Louder, children?
Ma'am, I can say the congruence rule, ma'am, for this one.
Who's that?
Kanishka, ma'am.
Okay, you're ready with the congruence rule, is it, Kanishka? And what about the equalities? Ready with the equalities? Okay, what's your congruence rule, Kanishka?
Miss AAS.
AAS. Not ASA, is it?
Yes, ma'am, it is AAS.
Okay, others, share your thoughts.
I think the same too. I think
Okay.
so too.
Okay, okay. So Satvika, tell me one pair of equality. Satvika, which are the two triangles you have to take up?
Ma'am, ABQ and ABP.
ABQ and ABP. Okay. Okay, Satvika. Kanishka, which angle of, we'll say this is the first triangle. ABP, we'll say the first triangle. ABQ, we'll say the second triangle. ABP, first triangle. ABQ, second triangle. Now, Kanishka, which angle of the first triangle is equal to which angle of the second triangle?
Angle 1 of triangle ABP is equal to angle 2 of triangle ABQ, ma'am.
Very good. Okay, Satvika, which angle? Now tell me another pair of equality. Another pair of equal angles.
Ma'am, since line L is bisecting angle A, angles 1 and 2 are equal, ma'am.
Don't you think that's what Kanishka just mentioned?
Ma'am, then angle BPA and BQA are 90 degrees, so both are equal.
So use the numbers which I've marked.
Angle 3 and angle 4.
Angle 3 is equal to angle 4 because both of them measure 90 degrees.
Yes, ma'am.
Okay. One more who can say not Kanishka, not Satvika. Somebody else? You ask yourself. Yeah.
Is
Can we?
common.
Okay, I have a doubt.
AP equals AQ.
Exactly. Even I wanted to ask the same thing. AP is equal to AQ. Who's that? You've just read my
Nivedita,
mind.
ma'am.
Nivedita. Now, Nivedita, the thing is, you have to justify every equality you write. So when we say 1 is equal to 2, 1 is equal to 2 because L bisects A is given. And when we say 3 is equal to 4, yeah, 3 is equal to 4 because 3 is 90 degrees, 4 is also 90. Now, Nivedita, please justify why AP is equal to AQ.
Ma'am, because the L bisects angle A into two parts, ma'am. So AP and AQ are equal. Is that right?
AP and AQ are line segments. Angle A, L bisects only the angle. From that, you have only one information. Angle 1 is equal to angle 2. That's all. Why should AP be equal to AQ? L bisects angle A. Angle is bisected. If it is 80 degrees, it becomes 40-40. That's all. It has nothing to do with the line segments AP and AQ.
Ma'am, BP is equal to BQ, ma'am.
Why? Reason, that's what everywhere.
Ma'am, they both are 90 degrees, ma'am.
Yeah, both are, that is angle 3 and angle 4. See, in this question, see here they were given to be in question number 3. They're given to be equal perpendiculars. Then CB is equal to DA. Equal perpendiculars. Equal perpendiculars. So 90 degrees, and since the perpendiculars are equal perpendiculars, AD is equal to BC. But it's not true always. Perpendicular means 90 degrees. That's all. So you're left with only one more option. You cannot write AP is equal to AQ because you cannot justify that. See, they may be equal, but as of now, we don't have a reason to, say that they're equal. So AP is equal to AQ is not given, and you cannot prove it also now. BP is equal to BQ is also not given. Perpendicular means 90 degrees, 3 and 4, 90. Which is the only other side available?
AB, ma'am, because it's the common side, ma'am.
Yeah, AB of the first triangle is equal to AB of the second triangle because common side. AB is a side common to both the triangles. That's the only option left. So AB is equal to AB common side. Now children tell me.
Even though if the angles are equal, we should not write if it's not given correct statement, ma'am.
Even come again, Nivedita.
And so, ma'am, for example, even though if AP and AQ are equal, we should not write that if we don't have a proper statement.
Yeah, correct. Now see, once you prove that the triangles are congruent, AP is equal to AQ, will be equal to AQ. That you cannot write now. Once the triangles are congruent, later, yes, you can say that they are equal because they're the corresponding parts of the congruent triangles. But now you don't have a reason. Before you prove that the triangles are congruent, since it's not given, you cannot use that information.
Yes, ma'am. Thank you, ma'am.
Yeah. Every equality must be justified. You should give a reason for every equality you write. We simply cannot write BP is equal to BQ. Why? Why is BP equal to BQ? Either it should be given in the question Or you must be able to prove that BP is equal to BQ. Okay. Now, answer this question. Which is the side contained by angle 1 and 4? Which is the side contained by angle 1 and angle 4?
AP, ma'am.
AP.
AP. Which is the side contained by angle?
A beam.
Yeah, which is the side contained by angle 2 and angle 3?
AQ.
AQ. Have we written AP is equal to AQ? Have we used that equality AP is equal to AQ? No.
No,
We have
ma'am.
not. So it cannot be ASA. We have mentioned two pairs of equal angles. Angle 1 is equal to angle 2, angle 3 is equal to angle 4. So we have two A's, AA. It cannot be ASA because if it has to be ASA, then it should be the included side. Included sides are AP and AQ. So then what's the congruence rule here?
AB equals AP, common side.
What's the congruence rule?
AS.
AAS, ma'am.
AAS, because it's two sides and some other angle. Two sides, some other angle. AAS rule the triangle, the congruent. Tell me the triangles in the correct order. Name the triangles correctly when they are congruent. If I say A, no, you name it. You name it. Children, name the triangles when they're congruent.
Triangle AP.
Ma'am, triangle ABP and ABQ, ma'am.
ABP and ABQ. Correct. ABP, ABQ. You can name it in different ways, but this is also right. ABQ, ABP, congruent to ABQ by the AAS congruence rule.
Ma'am, we can name it as AQB also, ma'am.
AQB congruent to?
No, ma'am, APB is equal to AQB.
Perfect. That's also right.
Yes.
Have a look at the proof, children. Yes, please try this one, children.
Ma'am.
BC is the side of which triangle, children? BC.
Triangle ABC.
Triangle ABC, ma'am.
BC is a side of triangle ABC. And DE?
Triangle ADE.
ADE, ma'am.
So you have to prove that these two triangles are congruent to each other. You should choose the triangle which has a side BC. Choose another triangle which has a side DE. Show that these two triangles are congruent to each other. Then through CP/CTC, it will follow that BC is equal to DE. So now what do you know in these two triangles? AC is the side of which triangle?
ABC.
ABC. This one of the first triangle is equal to, is AE a part of the second triangle?
ADE, ma'am.
ADE, ma'am.
So you can write this equality. AC of the first triangle is equal to AE of the second triangle, correct?
Yes, ma'am.
Yes, ma'am.
Okay. Which are the sides of triangle ABC? From the name you can make out, you don't have to see the figure. From the name you can make out AB, BC and CA are the sides of triangle ABC. AD, DE and AE are the sides of triangle ADE. You don't have to look at the triangle here in the figure. From the name or the names of the triangles, you can make out the sides. Okay, so AC of the first triangle is equal to AE of the second triangle. Okay, then AB of which triangle?
AB of triangle ABC.
is equal to
AD of triangle ADE.
Yeah, so another equality we have. Now it's about two sides.
AC.
It's about two sides. We have mentioned equalities. We have mentioned two pairs of equalities related to the sides. Then complete the conference. What are the options available? You have SS. What are the options available?
SAS and SSS.
Yeah, you have only these two, SAS or SSS. Because you mentioned two pairs of equal sides, then you should try to find if a pair of angles, and that too the included angles, are equal. If not, you should see if you have another pair excuse me, of equal sides. Which is a third, so apart from AC and AB, which is the third side of triangle, of this triangle, first triangle ABC?
AC of triangle
BC, ma'am. BC and DE.
Yeah, BC, and so we are left to the side BC. BC of the first triangle and DE. DE of the second triangle. I'm saying we have already two pairs of equalities of the sides. The third one is BC and DE, but we don't know if BC is equal to DE. That's not given. And you can no way prove that BC is equal to DE. So you cannot use this information BC is equal to DE because you don't have a reason to say that they are equal. We don't have a reason to say that BC and DE are equal. So that means you're forced to use SAS rule. You have to use SAS rule. You have to use SAS rule. Now to use the SAS rule, we have angle 1 is equal to angle 2. Angle 1 is equal to angle 2, but is angle 1 a complete angle of triangle ABC? See, this is triangle ABC.
No, ma'am.
No, ma'am.
Angle 1 is only this portion. There's the remaining portion 3. See here, there is 1 and 3 together, which makes this angle in triangle ABC. In triangle ABC, and the other triangle is ADE, right? ADE. Here we have a little, we have some portion of 2 and 3 here. This is the triangle ADE. ADE. We have written, we have mentioned AC. See here, AC is equal to excuse me. AC is equal to AE. Then AB is equal to AD. This is given. So which is the included angle? A only is included angle. See here, A is included angle. Angle 1 is equal to angle 2. So what you have to do is, we know that angle 1 is equal to angle 2, but that's not sufficient because it's not the complete angle. Add 3 on both the sides. You can add equals when these two are equal. Excuse me. Adding angle 3 to both the sides. So you'll have angle 1 plus angle 3 is equal to angle 2 plus angle 3. Add angle 3 to both the sides. So when you add angle 3 to both the sides, you will get the complete angle. You will get the complete angle BAC. BAC is equal to, you will get the complete angle EAD. EAD. Angle 1 is equal to angle 2. Adding angle 3 to both the sides. So that will make the complete angles on the two triangles. You will get this whole angle BAC is equal to this whole angle DAE. And that will make SAS rule. The triangle is congruent. CPCTC BC is equal to D. See the yes. Please get your doubts clarified. Any questions, children?
No, ma'am.
Ma'am?
Yeah.
Ma'am, in that adding angle 3 to both the sides you wrote, no, ma'am?
Yeah.
Ma'am, we can write directly that 2 plus angle 3 is equal to 180 degree, like that we can write, ma'am, directly.
Angle 2 plus 3 is 180, yeah?
Oh, sorry.
Okay.
No doubts, ma'am.
Okay. All right.
No doubts.
Okay, yeah. Yeah, try this one. Yes, you must actually write something in your book. Otherwise, just looking at the figure will not give you any idea. It's given here that you'll have to prove that DAP is congruent to EBP. So write out in triangle DAP and triangle EBP. List out the equalities you have. Yeah, try it in your book, children. And you can either share the picture or you tell me if you're finished and not able to share. I'll ask you to read it out here in the class.
Ma'am, we have to now prove and take a picture and share you on WhatsApp.
Yeah, correct. Yeah.
Miss, do you want to do this time, ma'am?
Yeah, please do it now. Please do it now. Please give it a shot now. Yeah, this is what you'll have to do, children. You'll have to take up the two triangles separately. DAP and EBP. See the two triangles separately. Mark the equalities given. Now somebody tell me. Do you see angle 1 equal to angle 2? Is angle 1 equal to angle 2?
Yes, ma'am.
Because it's given DAP. It's given not DAP. It's given here that yeah, it's given that BAD. See here, angle 1 is BAD, angle 1, and ABE, ABE. See, this is angle 2. Angle 1 is equal to angle 2. You can see angle 1 is an angle of the first triangle. Angle 2 is an angle of the second triangle. Then it's given that P is the midpoint of AB. P is the midpoint of AB. That means AP is equal to BP. AP of the first triangle is equal to BP of the second triangle. AP is equal to BP. And then angle EPA. Angle EPA is angle 3. This is angle 3. And this one is angle 4. Angle 3 is equal to angle 4. Add angle 5 on both the sides. Add angle 5 to both the sides. So you'll get angle 3 plus angle 5 is equal to 4 plus angle 5. Angle 3 plus 5 is this full angle. 3 and 5 make this complete angle. Otherwise, 3 is only a part of the angle at P. 3 and 5 together make this angle at P. 4 and 5 together, they make the angle here at P. Angle 3 is equal to angle 4. Add angle 5 to both the sides. So you will get angle 3 plus 5. Angle 3 plus angle 5, which is angle APD, which is a complete angle in the first triangle. Is not complete angle. I'm not trying to say 360 degrees. Of the three angles, it is one of the angles. And 4 plus 5. 4 plus 5. See here, 4 and 5 together make an angle of triangle BPE. So what's the rule you will get? You mentioned two pairs of equal angles, and you can see that the sides are the included sides.
AAS, ma'am.
ASA, ma'am.
ASA. ASA. ASA congruence rule, the two triangles are congruent to each other. Children, I did not tell you, but I hope you took screenshots, or you must have managed to write in the class, or you should have taken screenshots.
Yes, ma'am. We took screenshot, ma'am.
All right. So you can see it here. First, prepare this.
Ma'am, I have shared my picture, ma'am.
Yeah, okay. First, prepare this one, then write these two triangles. Take up the two triangles. Two pairs of equal angles, included side equal. ASA rule, they are congruent. Name the triangles in the correct order. And now you can see DA is equal to EB. DA is equal to EB, or AD is equal to BE, CPCTC. All right, children, I have another class now. It's time. Yeah, thank you, children. That's it for today's session. If you have any questions, you can ask me.
Ma'am, we can write EP is equal to DPB, ma'am. It's right, ma'am.
What, Kanishka? No, sorry, Shivani. What?
EPA is equal to DPB, ma'am. DPB.
But EPA, see, this is the triangle. Which is the triangle you've taken up? DAP, right?
Yes, ma'am.
See here, this is the triangle. This is the triangle, correct?
Yes, ma'am.
If you write angle 3, but the angle is still here. This is the angle. How can you say only this little portion angle 3?
Yes, ma'am. Yes, ma'am.
Similarly, in the other triangle, the other triangle is this one. EPB is the other triangle. This is the other triangle. If you say 3 is equal to 4, 4 is only this portion. It's not the complete angle. This is the full angle at P.
Okay, ma'am.
Yeah. All right, children. So that's it for today's session. Thank
you, ma'am.
Thank you. Thank you.
Thank you, ma'am.
Thank you, children.